For this exercise, we're dealing with a skeleton tower and we're asked three questions. How many cubes are needed to build this tower for part A? So if we were to look at this, we notice that we have 1, 2, 3, 4, 5 on this side, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. And then I notice that I have one of those 15 cubes. I have a second one, I have a third one, and then I have a fourth one. So I could write this as 4 times 15, but I still have this middle one right here. And if I know that this first one was 5 tall, I know that this one is going to be 6 cubes tall. So I'll just add that 6 right there. We know that 4 times 15 equals 60 plus 6, that's going to be 66. So how many cubes are needed to build a tower like this, but 12 cubes high? Justify your reasoning. So if we do the same thing as the last one and we just add them all in a descending order and then do times 15 plus that middle column, we know that we'll have 4 times 11 plus 10 plus 9 plus 8 all the way down until we get back to 1. Which, when we add all those numbers up, that's just going to be 4 times 66. And we have to make sure to add that last one. This one was 11, so we know the higher one is going to be 12. Then we get is 264 plus 12, which totals to 276. Now moving on to part C, we get asked, how would you calculate the number of cubes needed for a tower n cubes high? So this one we're going to be making a formula. And we know that when we look at one cube above, we have 1. When we look at one cube above and we have 1 sticking out from each side, we have 5. If I were to have if I were to have 2 cubes sticking out from each side, plus the one in the middle, I would have 9. So then a way I could write this one is 1 plus 4 from all cubes on the side equals 5. A way I could write this one is 1 plus 4 times 2, which equals 9. So instead of writing the 8 cubes as just 8, I broke it down to 4 times 2. And then that would eventually give me the equation 1 plus 4 times k minus 1. So if I wanted to see how many the next number would have, I would do 1 plus 4 times 4 minus 1, which gets us 1 plus 4 times 3. 4 times 3 is 12, plus 1, 13. That's how many cubes we would see from the top if we had 3 from each side sticking out besides the one in the middle. I'm going to go ahead and erase all this work really quick. And then if we want to look at the formula for how we would find total of cubes needed for a tower n cubes high, we would have the summation and then k equals 1 of 1 plus 4 times k minus 1. And then we could separate the summation by writing n k equals 1 of 1. Oh, yeah, plus n k equals 1 of 4 times k minus 1. Now, I could take out this 4 actually from right here, and I could just bring it out to the front of this summation. And then I know that if I keep plugging in numbers to this k minus 1 that I have right here, I know that I'll just get, if I were to plug in 1, then I would get 0. And I know that the more I keep going, I'll just keep getting bigger and bigger and bigger. So then I'm gonna erase this really quick. And this is an arithmetic series, and I know that's gonna be n minus 1 times n over 2. And then we had that 4 out front, so I'm just gonna bring that to 4 times that, which would equal 2n times n minus 1. Then we put that together, sorry, and we have the total would equal n times 2n times n minus 1, which would equal n plus 2n squared minus 2n, which when we factor that, we get 2n squared minus n. And this one right here would be our final formula. So if we wanted to do one, let's say it was one higher than this one, 7 cubes high, I would just plug in 7. So then I would have 2 times 7 squared minus 7. That would give us 2 times 49 minus 7. And then 2 times 49 would be 98 minus 7, which gets us to 91. All right, thank you for watching.